So I made several videos, but they were only very quick because I wanted to review some points. The thing is, when it comes to this specific topic, the Lewis structure and the VSEPR theory, it's so high yield for the IMAT and BMAT exam, so I really want to take my time and to take several videos, and I'm going to show you step by step how you need and how you can actually write, first of all, the two-dimensional structure of the molecule, then the three-dimensional structure of the molecule, based on the valence electrons. Now, we have the following elements over here. And the following elements are just naked elements right now. We are yet to draw the number of electrons they have. The first step when it comes to Lewis structure is to mention the number of valence electrons outside each element. For example, helium, group 1, single one. So you write a dot. Beryllium, group 2, 2 valence electrons. Carbon 4, nitrogen 5, oxygen 6, and fluoride 7. Now, the Lewis structure of molecules represents the covalent bonds between the molecule. And if you remember, covalent bond between a molecule is a sharing of pair of electrons. So it means once we share a pair of electrons, each one of the atoms that is basically sharing the pair of electrons is going to be it's going to get another electron, because you are sharing the electron of the other atom with a new atom. So you're basically gaining electron for both atoms, which means that we basically can create bonds based on the number of valence electrons we have on the outer shell. So I want to give a basic example of methane, for example. Methane is CH4. How do we actually write the Lewis structure of methane? First of all, we need to take the atom which is going to create the most amount of bonds as the backbone of the molecule, and it is going to be in the middle. So carbon is going to be in the middle. Then H, hydrogen, we know it can only share and has a single electron. So we have 4 hydrogen, 4 of them have 1 electron, and carbon has 4. What do we know about carbon? Because carbon has 4, he wants to get extra 4 bonds, extra 4 electrons, in order to complete the octet rule. Therefore, in order to get extra 4, it is going to share the electrons with the hydrogen electrons. So we are going to have this pair, this pair, this pair, and this pair. Each pair of electrons represents a covalent bond. And in the 2D structure that you're actually going to get from methane, you're going to get carbon with 4 covalent bonds. Carbon always going to reach and to strive to 4 covalent bonds. That's great. Let's get another example. Now for an example that is very common, but you're going to see something unique about it. So let's take water. Which one of the following elements can create more bonds? So hydrogen can create a single bond because it has 1 electron to share. Oxygen, on the other hand, has 6 valence shell electrons. Because it's a non-metal, it wants to get 2 extra electrons. 2 extra electrons mean 2 bonds that this element can actually create, which means this element is going to be in the middle, and the hydrogen is going to be on the outer layer. Now let's write, and again we are going to mention all the valence electrons. Hydrogen has 1, oxygen has 6, and we want to create pair of electrons. Where do you see that we can actually create pair of electrons? Over here. So we're going to have 1, 2 pairs. But we are not going to have a covalent bond for all of the electrons. We are still having 4 valence electrons. What are these 4 valence electrons represent? This 4 valence electron represents a lone pair of electrons. This lone pair of electrons is very polar, and when you have this lone pair of electrons, you're going to have one, the 3D structure of the following molecule is going to change according to the number of lone pair of electrons, and two, you're going to have the ability of the molecule itself to have dipole in the molecule, because electrons, of course, are very negatively charged. So you're going to have a molecule which is very charged. So not only that we have the difference of electronegativity between oxygen and hydrogen, we're also going to have two extra places in this water molecule that is basically going to be negatively charged. So if you think about it, this is the reason one water molecule can create 4 intermolecular forces with 4 other water molecules. So this one, but this one, and this one as well. So another water molecule is going to interact with one of these 4 structures, 4 dipoles. Let's get another example. I want to take the following molecule. So let's say C2H2. And let's try again using our following steps. So 1, you need to recognize the atom that can create the most amount of bonds. And as the backbone of life, carbon of course can create 4 bonds. We know it's the most amount of bonds carbon can form, because this is why it's the backbone of life. An element can actually form which is small enough to create the bonds. And 4 bonds are going to basically be in the middle. So carbon going to be in the middle. Hydrogen on the other hand is going to be on the outside layer, because it can only create only 1 bond. Let's try the electrons. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 1. Let's move it over here. Now let's create pair bonds. So again, covalent bond represent a share of electrons between the molecules. So we have one here and we have one here. So what do we have next? This time we have 3 extra pairs. So we have the ability to create 1 bond, and now we have also 2 electrons on both sides. They are not going to represent lone pair, because don't forget carbon can create 4 bonds, and we only have 1 here, 1 in between, and 1 here. So right now each carbon only has 2 bonds. What does it mean? It means that you can create 3, 4. So these carbons basically going to have triple covalent bonds, because they can create so many bonds, while these hydrogen and carbons are going to have a single bond. How did we reach this point? Because we know that they can create 4 bonds. Let's take another example. Let's say F2O. So fluoride can create 1, 2, 3, 4, 5, 6, 7. It has 7 valence electrons. So we know because it has 7, it is going to be able to create a single bond, because it wants a single electron. So it's going to create 1. Oxygen on the other hand wants to create 2, because it has 6. So therefore oxygen is going to be in the middle, while fluoride is going to be on the other side. Let's draw again the number of electrons we have on the outside. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6. What do we have right now? We are going to have 1, 2 bonds, and that's it basically. Because as you can see, now we have 8 electrons for this molecule, 8 electrons for this molecule, and 8 electrons for this atom, And the entire molecule is going to be stable. Each atom is going to be complete with the octet. So we are going to have a lot of lone pairs all over the molecule. It's going to be very, very charged molecule. However, we are going to have only a single bond between the fluoride and the oxygen. Let's take another molecule, just for the sake of the example. C2H4. C, again, backbone of life in the middle. 1, 2, 3, 4, 1, 2, 3, 4. H, outer layer, less bonds. 1, 2, 3, 4. Let's create the bonds here, 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 and here. how many bonds did we form for each carbon? 1, 2, 3, 4. Each carbon has 2 bonds right now. Let's add another one between the carbons because the hydrogen are saturated. And now we have 3 bonds for each carbon. We can add another one. So this carbon is going to have double bond. With this carbon, this hydrogen is going to have a single bond. So the molecule are going to be C double bond, H, 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 H. This is our molecule. So I hope this video made sense. This is just a very quick and easy way to draw the Lewis structure. Based on this Lewis structure, you are going to see that we are going to have more molecules in the future. I want to give another example actually. Ammonia is one of the most important biological molecules that we have, so let's take it. Let's take nitrogen and hydrogen. Ammonia is NH3. So let's take nitrogen, which is 1, 2, 3, 4, 5, and it is going to create how many covalent bonds? It is going to create 3 because it has 5 valence electrons. As a non-metal, it wants to get 3 extra, therefore 3 covalent bonds are possible. Then hydrogen is going to be on the outside. Now we have 1, 2, 3 bonds. However, we have a lone pair of electrons. So this molecule, even though the molecule has 3 bonds with nitrogen and hydrogen, you're also going to get a pair of electrons, a lone pair of electrons. And remember this lone pair of electrons, because having a lone pair of electrons is going to affect the molecule by a lot, because this lone pair of electrons has a charge and it is going to change the 3D structure of the molecules, which we are going to see in the next video.